11.4. So this time we're still talking about exponential functions, okay? But we're going to look at what it looks like in a word problem and what it looks like in a table and how you would solve those if that's what you come across on your STAR test, which you will come across this in your STAR test, okay? This is actually tested quite a few times on your STAR test, so this is something you really need to get down. If you are confused, please, please, please talk to me. I would love to help you. Now, on this first one, it is a warm-up, and I do want you to try it on your own, but remember, look at the formula right here. Your A is your Y value, where it crosses the Y-axis, okay? And your B is your growth or decay multiplier. So that's if it's growth, it's going up. It's greater than 1, and it tells you that right here. Growth is greater than 1. If it is decay, where it's going down like this, that means it is between 0 and 1. It's less than 1, and it's going down like this. So take a look at those answer choices and pick out which one would make the most sense for this equation. All right, now, again, remember, growth is greater than 1, decay is less than 1. A is your Y value, your initial value. Notice it says initial value. That is important, okay? Look at example 1. There are 30 beetles in an insect cage, so my initial value is 30 beetles. The beetle population increases, so this is going to be a growth, which means it is going to be greater than 1. So your B has to be greater than 1. Okay, by 15% each week. Write a function that can be used to find x, the number of beetles at the end of x weeks. Okay, so you should have everything that you need to solve this, okay? You have what your value is going to be, your initial value, you have what your growth is, or decay, but in this case, it's growth, right? So what we're going to do is we're going to put those together in that formula. X equals, now remember your initial value, your A, your Y value was 30. And then we multiply that by our growth or decay factor. This time it increased by 15%. Now, 15% is not greater than 1, is it? But if you start with 100%, right, and you add that 15%, okay, we know that this is really just 1 plus that 15, because 100% would give us that 1. And that means that we would do 1.15 to the power of x, x being the end of weeks, right? We don't know how many weeks, so we're going to leave it as x for now, but that's what it would be. But what did it ask for? It didn't ask for the entire formula like we did, but you need to get in the practice of trying the entire formula. It asked for the y-intercept, which you know is the initial value, which you found out was 30. Okay? All right, let's try example 2 together. There are 840 swimmers. That's our initial value. And in each round, 15% of them are eliminated. Now, 15% again, but think about the word eliminated. If you're disqualified, eliminated, kicked out, gone, got rid of, do you think that's increasing or decreasing the amount of players? Decreasing, right? It's a decrease. Oops. Decrease. So, we have a B that should be greater than 0, but less than 1. Okay. Now, let's kind of ride this out. And it says at the end of x rounds, again, we don't know what x is. We'll leave it as x. So, I start out. I know that I'm looking for f of x. I know that my initial value is 840 swimmers. And they continue to decrease by 15%. But think about it like this, okay? I am decreasing by 15%. I'm taking away 15 each time. If that's the case, what am I being left with? I'm being left with 85%. Every time I take 15% away, it leaves me with 85. So I am going to be decreasing by 0.85 or 85% for X number of rounds. And so which one of these answer choices matches that? A. All right, we're going to move on to the back page. We're going to do a few of those together and then a couple on your own. So let's move on. Remember, if I'm going too fast for you, you can pause, you can change the playback speed, you can do whatever you got to do, okay? The table represents some functions, some points on the graph of an exponential function. Write a function that represents the same relationship. So, for this one, if I'm taking a look here, I know that I'm going to use my best friend. Who is my best friend? Desmos. So, as you can see, I already put this into a table, but if you can't remember how to set up a table, you hit that plus sign up at the top, you hit table, and then you fill in your numbers, okay? So I filled in my x values, filled in my y or my f of x values, and it created dots for me. Now on yours for testing, you won't be able to do this. You won't be able to set that and it set a line or a scatter plot for you where you can choose this. But what you can do is you can, as you have this, sorry, put them back up on there, you can select each one, and I believe you can create a line, okay? I'm trying to figure out how I created the line earlier on your STAR test. This is something we will go through, is what your Desmos will look like when you take your STAR test, but you can imagine the line there, right? As you can see, we are regressing, right? We are decaying. This is a line of decay. In this line of decay, I have my y value. Remember, your y value is where it crosses on the y-axis. Where does it say it crosses on the y-axis? At 4. So I know that f of x is equal to 4 times my growth or my decay multiplier. Well, we know it's decay, so we know it has to be less than 1. Take a look at this pattern. How do I go from 16 to 8? 8 to 4. 4 to 2. What is happening every time there? Same thing here, right? How am I going from those numbers? I'm decreasing, right? By half. So, 0.5, or if you said half, for x number of times. Okay? All right. Let's check out example 4, and then you are going to try those last 4 examples on your own. But again, I am going to use my best friend Desmos. Okay, so we can get rid of this table. We're done with it. Get rid of it. Now, we can plug the table in again, kind of solve the same way we did last time, or because we have multiple choice, we could actually try it a different way. We can say, we use our little keyboard at the bottom, f of x, let me find my parentheses here, f of x is equal to, and I could try one of these answer choices. It doesn't matter which one. Let's say we try B, okay? That's not the answer. We're just going to try it. Is 18, and then times 6 over 5. All right, I just hit divide to get that over there, just in case you were wondering. And then close parentheses, and then make sure you do that a to the power of, and then we're going to put x because we don't know the length of time. Now, this is something that you can do on your Desmos for the STAR test. You are going to hit this right here, that little circle, little settings button, and you're going to choose table, and it creates a table for me. Notice, oh, move my Desmos. Is this table that it created the same as this table here? Well, let's take a look. We've got -1, 0, 1, 2. Okay, we have 15, 18. So this is actually correct, which I really did not do that on purpose. It was an accident. But what I did was I took one of these answer choices, okay, and I put it into Desmos. I hit my settings button, this little circular button here, and I created a table from what I put in, and I checked to see if the table matched up. I could do that again. Again, that was an accident. I didn't mean to put in the correct answer there, but if I were to try out a different one, I can test it as well and make sure. So let's try A, for example. I would try 15, parentheses, 5 over 6, close parentheses. Nope, sorry, not there. Make sure you go out one because we don't want it right there. We want it out here, to the power of x. I'm going to hit the settings button. I'm going to hit table. Notice, this is different. I don't go from 18 to 15 to 12 to 10. That is not what this table is doing, so A cannot be the correct answer. B has to be it, okay? All right, I'm going to put Desmos away for just a second, but remember, you can always use that. That is your best friend. Take a look at these last 4 examples, okay? You are still using this right here, this formula right here to do your function. You are going to try example 5, example 6, example 7, and example 8 on your own, okay? I will see you for notes 11.5, and I hope that these will be in your algebra folder.